Odd and even functions. Odd and even functions are related to symmetry. Symmetry about the y-axis and symmetry about the origin. So first, let's check this out. If you guys have an even function, this is what I think of. Let's see, we've got even function. I always think of x squared. And I think of x squared because 2 is even. I think of this, and it works every time. If I graphed x squared, it would look like this. And we know it's an even function because it has symmetry about the y-axis. Now, I just want to talk about the graphs, but I also kind of have to talk about the function notation stuff too. We'll get to the function stuff next unit. This unit, I just wanted to look at graphs. So if I was to look at the actual function, we're not going to get too detailed. I just want to see the function. And I plugged in an x, a negative x into that function, it will give me the same thing as f of x. So, like, if I were to plug in, here, let me do the visual thing. If I were to plug in positive x, I would get this value, right? Well, if I plug in negative x, which is the same distance away from 0, I get the same value. Does that make sense?
Yep.
So that's why f of negative x equals f of x. That means that the function is even. It means that it has symmetry about the y-axis. So if it's even, you know it has symmetry about the y-axis. Okay? Now let's check out the next one.
We finished the. Do you want us to?
Now for odd functions, I always think of the x cubed. Let's see, we'll use g this time. G of x equals x to the third power. When we graph x to the third power, it looks like this. Okay, my graph's not perfect, but it's not as clean looking as the symmetry about the y-axis, but this one does have symmetry. It has symmetry about the origin. Symmetry, I'll write down the symmetry about, oh, I don't know how to spell about, origin. Okay, so if you were to take a negative x and plug it into this one, you're going to get negative f of x. And so let me go visual again. If I plug in a positive x right here, I will get this f of x. I'm saying f of x instead of y, okay? Or I could say y, whatever. I think you guys like y better. If I plug in a positive x, I'll get that positive y. If I plug in the same x but the opposite way, so it's a negative x, then I'm going to get a negative y. Make sense? Makes sense. Oh, I didn't write the points. So for this one, it would be xy. If you have this point right here, you would also have negative x and negative y. For the symmetry about the y-axis, if you had xy, then you would also have negative x and then the same y. Okay, so that's, I don't know, a bunch of different ways to look at it, a bunch of different ways to see it. Just know that if you have an even function, it's symmetry about the y-axis, odd function, symmetry about the origin. So let's take a look at some examples really quick here. Here's a function, and here's its graph. Okay, what does this graph have? I mean, is it even, is it odd, or is it neither?
Odd.
We know it's odd. How do you know it's odd? A symmetry about the origin. Okay, so we know that this is an odd function. Okay, what about the next one? Odd, even, or neither?
Even.
It is even. I'll check that out too. It has an even degree. See how this one has an odd degree? I wonder if it always works out like that. No, it doesn't. But just thinking out loud. Okay, so this one is even. And now we have the last one, even function. I tried to be tricky on this one. Because look, it's a parabola. Remember before, our parabola was symmetrical about the y-axis. Is this symmetrical about the y-axis? No. No. Is it symmetrical about the origin?
No.
So is it odd, even, or neither?
Neither.
It is neither. You say neither, I say neither. Da 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 da. Okay, done with that.